Hi everyone. In this lecture, we are going to see testing of hypothesis for small sample, namely t-test and f-test. In t-test, the second method we are going to see. So, test of significance of the difference between means of two small samples. So, to test the significance of the difference between two means x1 bar and x2 bar of sample of size n1 and n2 respectively. Now we use the statistics. T is equivalent to x1 bar minus x2 bar divided by capital S into root of 1 by n1 plus 1 by n2, where capital S is equivalent to square root of n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. With the degrees of freedom, mu is equivalent to n1 plus n2 minus 2. So n1, n2 are the sample sizes. So n1 and n2, and the x1 bar, x2 bar. First sample mean x1 bar, second sample mean x2 bar. S1 square, the first sample variance, second sample variance denoted by S2 square. So sometimes we use the notation instead of x1 and x2 we use xy. We see the problem first. First problem we are going to see. The nicotine content in milligrams of two samples of tobacco were found to be as follows. So sample A, sample B, two sample values are given. So sample A, the observations are 24, 27, 26, 21, 25. Second sample 27, 30, 28, 31, 22, 36. So can it be sending that two samples come from normal population with the same mean? So now we are talking about the mean with the two samples. So we can use two sample mean test. Solution we will see now. So first we have to choose the null hypothesis, which means that both are same. That is the two sample means are same. That is the two sample come from normal population with the same mean. So mu1 is equivalent to mu2. There is no significant difference between sample mean and population mean. The alternative hypothesis we chose h1 by mu1 not is equivalent to mu2. So there is some significant difference between sample mean and population mean, which means both are not same. So here only the observation values are given. So first we have to compute all the values, namely a mean, standard deviation, that is a variance, and then we can do. So here we choose the level of significance should be 5%. With the degrees of freedom, n1 plus n2 minus 2, that is 5 plus 6 minus 2, n1 is 5, n2 is 6. So we simplify this, we can get 9. So now we have to find out mean and standard deviation and nothing but a variance. So first we have to calculate. So the value, first we have to choose x values. 24, so take the square, 576. 27, take the square, 729. 26, take the square, 676. 21, 441. 25, 625. Summation x is nothing but 123. We can add all these values. In the summation x square value is 3047. So take this sample and we calculate a variance by using the formula summation x square by n minus summation x by n whole square. So summation x square value is 3047, n value is 5, and minus summation x value is 123 divided by 5 whole square. So after simplifying this, we can get s1 square is nothing but 4.240 Similarly, we can calculate for y. So the second sample observations are 27, corresponding y square is nothing but 729, 30, 900, 28, y square value is 784, 31, y square value is 961, 22, 484, 36, 1296. So summation y is 174 and summation y square is 5154. So we can calculate the variance of the second observation, second sample. S2 square is equivalent to summation y square by n minus summation y by n whole square. So 5154 divided by 6 minus 174 divided by 6 whole square. So 859 minus 841. So S2 square is nothing but 18. So first we calculate capital S square. So by using the formula n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. So substitute all these values. That is n1 value is 5, s1 square is 4.240 plus n2 value is 6, s2 square value is 18 and divided by 5 plus 6 minus 2. So simplify this, we can get 14.356. So capital S is equivalent to, take the square root, so we can get 3.79. Now we can use the formula. So t is equal to x bar minus y bar divided by capital S into root of 1 by n1 plus 1 by n2. So x bar value is 24.6 minus y bar value is 29 divided by capital S value is 3.79 into square root of 1 by 5 plus 1 by 6. So we simplify this, we can get minus 1.92. So t value, take the absolute value, so modulus of t is plus 1.92. And table value we can choose 5% with the degrees of freedom. With the degrees of freedom 9, the value is 2.262, which is shown in the table. So with the degrees of freedom 9, for 5% two-tailed test 2.262. So our calculated value is 1.92. Calculated value is 1.92 and the table value is 2.262. So our calculated value is less than the table value. Therefore we accept null hypothesis H0. That is, we go back the problem and see that one. So what the conclusion we can have? So there is no significant difference between sample mean and population mean. That is, the two samples have come from the normal population with the same mean. Second problem we are going to see. Samples of two types of electric light bulbs were tested for length of life and the following data were obtained. So we have two type of electric light bulbs. So type 1, sample number is N1 is 8, type 2 N2 is 7, sample mean x1 bar is nothing but 1234 hours, x2 bar 1036 hours, sample standard deviation S1 is 36 hours, S2, this is nothing but S2 is 40 hours. So is the difference in the means sufficient to warrant that type 1 is superior to type 2 regarding length of life? In the average length of life we have to analyze that electric bulbs. So two sample data are given. So we need to check, is there any significant difference between the two sample means. So we use t-test. So now we fix the hypothesis, null hypothesis H0 and alternative hypothesis H1. So mu H0 is nothing but both are same. So mu1 is equal to mu2. There is no significant difference between type 1 mean and type 2 means. And the second one, alternative hypothesis, we chose mu1 is greater than mu2. That is, there is significant difference between first sample and the second sample mean. So level of significance, we can choose 5% with the one-tailed test. Degrees of freedom, n1 plus n2 minus 2. So 8 plus 7 minus 2 is nothing but 13. And we use the statistics. T is equal to x1 bar minus x2 bar divided by capital S into root of 1 by n1 plus 1 by n2. So first we can calculate capital S square. So n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. So n1 is 8, s1 square is 1296 plus n2 value is 7, s2 square is 1600. So divided by 8 plus 7 minus 2. So we simplify this, we can get 1659.08. Therefore we can calculate S. So take the square root 1659.08, take the square root of this value, we can get 40.73. So now we got x1 bar, x2 bar, capital S, n1, n2. So all the values we have to know. So now we apply the formula T is equal to x1 bar minus x2 bar divided by capital S into root of 1 by n1 plus 1 by n2. So substitute these values here, we simplify, we can get 9.39. So take the absolute value. So here we have only the positive value, therefore 9.39. Now table value we can see with the degrees of freedom 13, the 5% level of significance, so 1.77. So I shown here. So with the degrees of freedom 13, 5%, so 1.771. So now we can get the conclusion. Our calculated value is 9.39, but table value is 1.77. So our calculated value is greater than the table value, therefore we reject the null hypothesis. So this is the conclusion. So we can accept the alternative hypothesis H1. So the next one is paired t-test we are going to see. That is, there is some relation between two samples. We can use paired t-test. So the formula is T is equal to D bar divided by S by root of n minus 1, where D bar is nothing but summation D by n, and S square is summation D minus D bar whole square by n, with the degrees of freedom n minus 1. So we can see by an example. So we look at the problem. The following data relate to the marks obtained by 11 students in two tests, one held at the beginning of the year and the other at the end of the year after intensive coaching. So test 1, test 2. So the values are given: 19, 23, 16, 24, 17, 18, 20, 18, 21, 19, 20. Second test 17, 24, 20, 24, 20, 22, 20, 20, 18, 22, 19. So do the data indicate that the students have benefited by coaching? So test 1 marks are given, then after intensive coaching we have test 2 marks. So based on this data, okay, we have to check the students have benefited by coaching or not. So the same set of students, but the marks are different. So there is some relation between these two, right? So we can use paired t-test. So this is the given. So the given data relate to the marks obtained in two tests by the same set of students. So hence the marks in the two tests can be regarded as correlated. So we have some relation. So we can use paired t-test. So now we can choose the null hypothesis H0. X1 bar is equivalent to X2 bar. The coaching is not useful. That is both the average is same. So there is no significant difference. So the coaching is not useful. So once the X2 bar is greater than the X1 bar, then the coaching is very useful. So likewise we have to choose the alternative hypothesis H1. X1 bar is less than X2 bar. The coaching is useful. So degrees of freedom is n minus 1. So here observed values are 11. So 11 minus 1 is nothing but 10. So now we can take the first observations. So test 1 x1, second one x2. Then we can calculate the difference. So 19 minus 17 is 2. 23 minus 24 is nothing but minus 1. 16 minus 20 minus 4. 24 minus 24 is 0. 17 minus 20 minus 3. 18 minus 22 minus 4. 20 minus 20 is 0. 18 minus 20 minus 2. 21 minus 18 3. 19 minus 22 minus 3. 20 minus 19 is 1. So D minus D bar. So D bar, so D is nothing but this one. So my total summation value is minus 11. Take the D bar. So and subtract with this. So D minus D bar is nothing but 3. So 0, minus 3, 1, minus 2, minus 3, 1, minus 1, 4, minus 2, 2. So based on this we have to take the square. So 9, 0, 9, 1, 4, 9, 1, 1, 16, 4, 4. So the total value is nothing but 58. So here we can apply the formula. T is equivalent to D bar divided by S by root of n minus 1, where S square is nothing but summation D minus D bar whole square by n, and the D bar is nothing but summation D by n, that value is minus 1. So we can calculate S square. So summation D minus D bar whole square is nothing but 58 and n value is 11. So we simplify this, we can get to 5.27. Therefore S is 2.295. So now we substitute in the formula. T is equal to D bar by S by root of n minus 1. So minus 1 divided by 2.295 divided by root of 11 minus 1. We simplify this, we can get a minus 1.38. So take the absolute value. So T is equivalent to 1.38. With the degrees of freedom n minus 1, n value is 11. So 11 minus 1 is 10. So for the tabulated value for 10 degrees of freedom at 5% level of for one tailed test is 1.812. So we can get this value from the table. So modulus of T is 1.38 and here table value is 1.813. So calculated value is less than the table value. So we can accept the null hypothesis. So we accept the null hypothesis. The course is not useful. That is does not increase. Therefore the course is not useful. So the next one is F test. So far we had seen T test. Now we are going to see F test. So to test whether if there is any significant difference between two estimates of population variance, we use F test. So the simple formula, F is nothing but greater variance divided by smaller variance. So we can use the formula capital F is equal to capital S1 square divided by S2 square, provided S1 square is greater than S2 square. So where S1 square is calculated by N1 S1 square divided by N1 minus 1. S2 square is calculated by N2 S2 square divided by N2 minus 1. With the degrees of freedom nu1 comma nu2. So N1 minus 1, N2 minus 1. So note, if S2 square value is S1 square, that is S2 square is greater than S1 square, then we can use the alternative formula capital F is equal to S2 square divided by S1 square. With the degrees of freedom nu2 comma nu1. So S2 square with the degrees of freedom is nu2. So N2 minus 1 comma N1 minus 1. In note 2, if the population variance are given directly, now we can use the formula F is equal to sigma 1 square by sigma 2 square, provided sigma 1 square is greater than sigma 2 square, and sigma 2 square by sigma 1 square if sigma 2 square is greater than sigma 1 square. We can see the first problem in F test. A sample of size 13 gave an estimated population variance of 3, while another sample of size 15 gave an estimate of 2.5. Could both samples be from population with the same variance? So we need to analyze about the variance. So we use F test. So now we can choose the null hypothesis H0. The two samples have come from population with the same variance. An alternative, so both are not same. So variances are not equal. So sigma 1 square not equivalent to sigma 2 square. And from the given problem, we observed N1 value is 13, N2 value is 15, sigma 1 square is nothing but 3.0, sigma 2 square is 2.5. So here population variances are given directly, therefore we can use the following formula. So F is equivalent to sigma 1 square by sigma 2 square, because sigma 1 square value is greater than sigma 2 square. So 3.0 divided by 2.5 is equivalent to 1.2. And table value, we can refer the F table with the degrees of freedom nu1 comma nu2, namely n1 minus 1 comma n2 minus 1, that is 13 minus 1 comma 15 minus 1, that is 12.14. So for this we can get table value with the 5% level is 2.53. So our calculated value is 1.2, whereas the table value is 2.53. Therefore our calculated value is less than the table value. We accept the null hypothesis. Second problem. Two independent samples of sizes 9 and 7 from a normal population had the following values of the variables. Sample 1 values are given, sample 2 values are given. Do the estimates of the population variance differ significantly at 5% level of significance? So we need to analyze about the population variance. So we can use F test. So now from this sample 1 and sample 2, we observed that N1 value is 9 and N2 value is 7. So now we can choose the null hypothesis H0. Sigma 1 square is equivalent to sigma 2 square. So variances are equal. So two variances are equal. Alternative hypothesis H1. So sigma 1 square is not is equivalent to sigma 2 square. That is variances are not equal. Alternative hypothesis we may choose like this. And level of degrees of freedom is given 5%. So first we have to find out S1 square and S2 square. So take the first sample x, the values are 18, corresponding x square 324, 13, x square value is 169, 12 144, 15 225, 12 144, 14 196, 16 256, 14 196, 15 225. So from this we can get summation x value is 129 and summation x square value is 1879. So from this we can calculate the variance S1 square by using the formula summation x square by n minus summation x by n whole square. So is equivalent to 1879 divided by 9 minus 129 by 9 whole square. So if we simplify this, we can get 3.34. We can get 3.34. So capital S1 square we can calculate by using this formula, n1 S1 square divided by n1 minus 1. So 9 into 3.34 divided by 9 minus 1, that is 3.76. So capital S1 square value is 3.76. Now the second sample y. So the values are 16, 19, 13, 16, 18, 13, 15, and we can see y square value. So 256, 19 square is 361, 13 square is 169, 16 square 256, 18 square 324, 13 square 169, 15 square 225. So we can take the summation y is 110 and summation y square value is 1760. So from this we can calculate S2 square by using the formula summation y square by n minus summation y by n whole square. So 1760 by 7 minus 110 by 7 whole square. So first one simplification is 251.43, second simplification is 246.94. Therefore we simplify this, we can get S2 square is equal to 4.49. So based on this we can calculate capital S2 square. It is nothing but n2 S2 square divided by n2 minus 1. So 7 into 4.49 divided by 7 minus 1. So by using calculator we can get 5.24. So S2 square value is 5.24. So now we got capital S1 square and the S2 square. And now we choose the suitable F-test formula, that is nothing but greater variance divided by smaller variance. So now we can apply the formula. So here S2 square value is greater than the S1 square value. So now we can use this formula S2 square divided by S1 square. So 5.24 divided by 3.76. So we simplify this, we can get 1.39. So greater value is nothing but S2 square. So the degrees of freedom mu1 comma mu2 is nothing but the greater variance is nothing but S2 square, right? So n2 minus 1 comma n1 minus 1, that is 6 comma 8. So for 6 comma 8 the table value is 3.58. So now we see the calculated value is 1.39 and table value is 3.58. So our calculated value is less than the table value. Therefore, we accept the null hypothesis. That is, the two samples are drawn from population with the same variance. So one more problem I shown here. We observe this. Time taken by workers in performing a job is given below. Method 1, 20, 16, 26, 27, 23, 22. Second method, 27, 33, 42, 35, 34, 38. So test whether there is any significant difference between the variances of the time distribution at 5% level of significance. So this problem also similar to the previous one. So we can calculate capital S1 square and capital S2 square. So based on that, we can check greater variance and the smaller variance, and then apply F test, and then get the table value from the table, and compare with calculated value and table value and get the conclusion. So this problem is similar to the previous one, so easily we can able to solve. Thank you.